Hello there, I'm John Everest, and I have another short presentation on the limitations of making your daylight simulations using the three-phase method. I just highlight there it's actually a limitation of working with bidirectional scattering distribution function materials. But I'm linking this to daylight, the three phase method. So what I have to, as an example here, is just a very simple room I've made in Grasshopper. It's a simple classroom. It's roughly 7 meters by 7 meters by 3 meters. Not that that's particularly relevant, to be honest. And I have two windows. One, two. Here are the windows. I also have some blinds. In fact, what I'm going to do is I'm just going to turn off the ceiling and the floor and the exterior surfaces so it's just crystal clear. Just for some context, this is where my camera is. Camera's here, looking there. You'll see that in a minute. And here are the blinds. The blinds and the windows are the crucial bits we're looking at here. It is a limitation of when you simulate fenestrations that leave sharp patterns, and we'll just get over to that. But I think that's all nice and clear, isn't it? So if I just render it using the classic Radiance render, it looks something like this. And what I want you to be aware of is what I want you to be aware of is I'll just use these boxes. Look at these patterns. Come on, PowerPoint. Format shape. Fill. No fill. Look, notice these patterns here, right? Oh, right, forget that. You know what I'm talking about. So you've got these clear patterns that are created by the blinds that we just saw. So the lights, it's I don't know. I think I set it to like March or something like that. It's midday March, and we're having these patterns from the sun coming in, which is what you'd expect if you had blinds of that type. Yeah, so perhaps just to give you some context there, this is the pattern. So that is a nice accurate render. It's two ambient bounces. Excuse the crudity of the distribution. I just wanted it to be a quick calc. Now, if I was going to do a three-phase method, what I would be doing, as I've previously discussed, is I would be calculating the daylight phase, the window phase, including any fenestrations, then the interior phase. So you'll be doing them separately. So the way it would work here is that when we did this actual view that we're seeing here, the calculation would be done with these windows actually as light sources. So they would collect the light from the sky behind it and factor in the redistributed light as a result of the fenestrations we're talking about and put the light into the room. The way we do that is we take one example of the fenestration. So here's one window, and you basically sort of light it down like so. Here's the window with the blind underneath it, and you do on its own with nothing else in the model. You trace your rays of light through that, and you build up think of it as a photometric description of the window. So in the same way you have an IES file for luminaires, think of it just as an IES file for windows. So when you repeat the calculation, this is the result. Okay, so there's obviously a clear difference going on, and what I'll do is for context, I will just stick that up there. And there's the two things I want you to be aware of is the pattern has gone. Yeah, because what happens is when you trace your light rays through, the end result that it gives you is the average of the entire surface. So there is no, whereas in reality, back here, as we different areas of the window have different distributions, as in totally abstracted, not abstracted. The way the bidirectional scattering distribution function material works is it just takes the average of the whole thing. So you end up with this. The quantity of light entering the space is the same. If I was a bit more organized, I would have saved my radiance outputs. I could have shown you the false color image, but take my word for it, the quantity of light in the space is as near as exactly the same. It's just that you've lost all those patterns, but this quantity of light in this shape here will be the same if you took the average of the quantity of light up here. So you lose all that detail. The other thing to note is that where there is you can kind of just see it through that. I didn't bother making it, but can you see behind it? There's a ground and a sky. You lose all that as well if you're doing a visualization. And it is simple as that. That's just what I wanted to make you aware of. So note that you lose the intricacies of the pattern. The quantity is the same, but the distribution gets averaged, and you lose any views through the window. If you want to get around that, you got two options. One is to use just a classic renderer as I did before, and there will be time implications for that. The other way is use the 5-phase method, which is which may be what you need for this type of thing. Again, it's as I've mentioned before, it's not that the 3-phase method is inaccurate or it's no good. You simply have to be aware of is that when you're looking through your calcs, or maybe you're not doing a visualization, you're just doing a numerical analysis. Just remember that in something like this, there would be stripes, but it's not showing up in your calc. That's the cost of the optimization. So it's just another thing to be aware of. I hope that's useful to you all. Thanks for watching.